In this video, we are going to determine the surface area of a cone. An example of a cone is an ice cream cone, traffic cone. So those are examples of a cone. So please remember that surface area refers to the sum of all the areas that cover the solid. So in this example that we have here, this is a picture of a cone. So the surface area of this cone would be the walls of the cone. So this wall that makes up the cone, and then the bottom, or which is at the base. If we add all the surfaces of the wall of this cone plus the area of the base of this cone, then that is the surface area. Others call this the total surface area. So this is the formula for the surface area of a cone. So S represents the surface area, pi r squared plus pi rs. So the r here represents the radius. So radius is from the center to the side of the circle. And then the S that we have here, because there are two heights here, I label them differently. The S represents the slant height. So it's the height that that's coming from the tip all the way to the circle, or to the side of the circle, to the point on the circle. While the height h that we have here is from the tip all the way to the center of the circle. So that's the difference between the slant height and the height. In this problem, or in getting the surface area of a cone, we are using the slant height and not the height. Okay, so please remember that I've mentioned in the beginning that surface area is the sum of all the area of all the surfaces that cover the solid. The first one that we have here is, this represents the area of the circle. So that's the area of the circular base. So this area right here, so the to find the area of the circle, we have this in a previous video, it's pi r squared. So this is the area of the bottom, or the base. Now this one right here is, we call this as the lateral area. So this is lateral area. Lateral area means this is the area that does not include the base. So this is just the area of the wall. So the area of the wall. So that's the easiest way to remember what a lateral area is. So the lateral area is the wall that makes up this cone, while this one right here is the area of the bottom, or the base. So if we add the wall area plus the base area, that's the total surface area of the cone. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we have here the formula for the surface area. So we got that in the first slide. So we plug the values in. But before we do that, let's label the parts first. So our 10 here is representing the radius of the circle, which is the base of the cone. The 19 that we have here is our slant height, letter S. Again, it's the slant height that we need in order to find for the lateral area. So in this problem that we have here, we plug in the values. So we're looking for S. I'm just going to label this as S. Again, our pi is 3.1416. And then the radius that we have here is 10 meters. And then we're supposed to square this. Plus, again, the pi, so that would be 3.1416. The radius, again, is 10 meters. And then the slant height is 19. So that's 19 meters. And then from here, we are going to square this one first. So that would come out 3.1416 times 100 meters squared. And then plus, if we are going to multiply all these, this would come out 596.904 meters squared. Now let's simplify these two by multiplying them together. So this would be 314.16 meters squared plus the one that we got here, 596.904 meters squared. Now, in this problem that we have here, this is the area of the circular base. So that's circular base. This is the area of this circle right here that covers this cone. And then this part right here is the lateral area. Again, remember, lateral area is the area of the wall that covers the cone. So this is the area of the circular base. This is the lateral area. Lateral area is the area that does not include the base. So pretty much the area of the wall. Now, if we find the total surface area S, we're going to add the area of the wall or the lateral area plus the area of the base, which is a circle. And so the total for this is 911.06. I rounded it off. That's meters squared or square meter. So this is the answer for this problem right here. Did you get the same answer as this? Good. Perfect. Now let's move on to the second problem right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. This is pretty much like doing it backwards. I give you the surface area and we are supposed to find the slant height, or I represented this as letter S. So if we label this, our 5 inches that we have here is the radius of this cone. And then the S here is actually the slant height. S. So from this, from the given that we have here, we plug this into the equation that we have. That would be 300, and so I'm going to put in the S first. So our surface area is 345.576 inches squared is equal to the pi, which is 3.1416 times the radius is 5 inches. And then this is supposed to be squared plus 3.1416. And then the radius again is 5. So I'm going to write 5 inches here. And then we are missing the slant height. So I'm just going to write letter S at the end. Now we are going to simplify this one right here. So 345.576 inches squared is equal to 3.1416 times 25 inches squared. Plus, now if we multiply these two together, that would come out 15.708 inches times S. Again, the S, which is represented as the slant height, the height that comes from the tip to the point on the circle is our slant height. So then from here, we're going to multiply these two. So 345.576 inches squared is equal to, when these two are multiplied together, this would be 78.54 inches squared. And then plus 15.708 inches, and then the S is missing. Now we combine like terms. All the inches squared will be placed on the left side of the equation, so that is minus 78.54 inches squared minus 78.54 inches squared. So then we can cross the 78.54 inches squared out, so we're left with 15.708 inches, and then the slant height on the right side, that's the leftover. And then if we subtract this, that's 267.036 we have inches squared. Now we want the S by itself. So what are we going to do is we are going to divide both sides by 15.708 inches, and then that's 15.708 inches. So we can cross out the inches, 15.08 and 15.08. So then we are left with S, which is the slant height again in this side of the equation. Now please take note that in this numerator that we have here, inches squared means there are 2 inches unit here, and then there's 1 inch unit at the bottom. So that means we can cross one of the inches, one of the 2 inches here, so we're left with 1, and then we cross out the inch that we have at the bottom. So then if we divide these two together, this would come out 17. The final unit now, since we crossed out one of the inches here, is already inch, and this is our slant height. So that means this is the height that comes from that starts from the tip of the cone all the way to any of the point within the circular base, and that is 17 inches. Did you get 17 inches for your slant height for the second problem right here? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!